All right, my friends, let's see how it went. So for part A, first let's figure out what dy dx is. Let's see, taking the derivative, not the antiderivative. So we get x to the fourth over 2. Now a note here, just to keep us from doing anything crazy, this is the same as 1/6 times x to the negative 3. So the derivative there would be negative 1/2. And then x to the negative 4, essentially. And actually, you know what's funny is I'm better off with it because I'm going to use my calculator later. So I'm actually better off with it like that as opposed to writing it without a negative exponent. Okay, now setting up the arc length integral. So we'll have arc length is equal to the integral from 1 to 2 of the square root of 1 plus, and then just insert dy dx here. So I'll write 1/2 x to the fourth minus 1/2 x to the negative 4 squared dx. There you go. Now it's just a matter of punching it into your calculator. There we go. And looks like we end up getting approximately, let's see, 3.246. And it's arc length. So I hope it makes sense. You just have units, not square ones or cubey ones. There you go. Hopefully that makes sense. Okay, for part B, let's take dx dy. Just a note there, dx dy is also known as f prime of y. Okay, and so we would end up with, oh good times, 1/2 times 36 minus y squared to the negative 1/2, and then times the derivative of the inside function. Don't forget chain rule. And we're taking the derivative with respect to y, so we get negative 2y there. And then as far as simplifying this down, since I have to punch it into my calculator anyway, you know, up to you how you want to do it. I think I'll just go ahead and cancel the 2's. And then I'd have negative y over the square root of 36 minus y squared, like that. And that's for f prime of y. Okay, so my setup for arc length then would be the integral from -6 to 0 of the square root of 1 plus f prime of y squared dy. Almost said dx there. Oops, make that a little more purposeful looking. All right, and then for me, before I punch it in on this one, I do like simplifying it simply because the square and does the square root down there. Boy, I have a habit of writing dx, don't I? Anyway, so I'd probably simplify it that much and then punch it into my calculator from there. And when it's all said and done, you should get approximately 9.425. And since it is arc length, it would just be straight units. There you go. All right, my friends, that's it for section 6-4, part 1. Hopefully things are making sense, and hopefully you'll ask questions if things aren't making sense. Take care, everybody.